Alright, I'm here to go over the answer key. This is a study guide for y'all. Number 1 and number 2 says, given the graph of the function and its parent, write the equation of the function. We're looking for the new function, and if you remember from the start of the unit, the parent function always goes to 0, 0. I know these numbers are pretty hard to see, and the scale is even worse, but this is -1, -2, -3. I told you guys in class, A is either only going to be 1 or -1. We did not have time to solve when there are cases where A is not 1 or -1. I was really hoping to get to that this year, but we didn't. So here, because there's no reflection, this new equation, this new function is still just 1. H. In this case, we're looking at comparing this point to this point. H went over 1, 2, 3. Therefore, H is -3. K, we're going to look out down 1, 2, 3, 4, 5. So it went down 5 points. And I know that's really, really hard to see. Forgive me. I'm sorry. Next thing we're going to do is we're going to plug these values in to the general equation of the transformation. If you don't remember what that is, there's a poster at the front of the class that says it's f of x is a times x minus h plus k. The trick here is understanding what your parent function is. So if the parent function is x squared, we need to make sure that somewhere in our equation we are clear that we're doing an x squared function. Therefore, we have f of x is 1. Let me make this orange. 1 times x minus -3. And then this is where we say it's squared. Then we're going to do plus -5. If you leave it like this for the test, I will most likely give you credit, but as a mathematician, it's going to hurt me. I want you to write it nice and clean, nice and beautiful. So 1 times something, we don't rewrite. We don't write the multiplicative identity. Then we have x. When you subtract a negative, what you're really doing is adding. Squared, and then plus -5 minus 5. This would be your answer for number 1. Number 2, we're going to do the same thing. Is there a reflection? Did the graph go from pointing up to now pointing down? The answer is yes. So A is a -1. Our H value looks like we went over 1, 2, 3. So H is +3. And then K, we're looking at how much it went up, which is 1, 2. The numbers are a little bit more clear here. Again, I'm sorry. And now, what type of graph is it? It's a V shape, and it tells us here it's an absolute value. So somewhere in your function, you need to make it clear that we are talking about an absolute value function. We're still going to plug it into this equation, but instead of parentheses, we have to have our bars. So A is -1, x minus, in this case we're going to have +3, and I already messed up. This should be an absolute value bar. And then plus k is +2. If you want to make it as clean as possible, again, we don't write our negatives, or we don't write our ones. So f of x equals -x minus 3 plus 2. On number 1 and number 2, all you have to do is write the new equation. It needs to look like this. So f of x equals something. Number 3. Number 3 is asking us to sketch and find all the key features. I'm going to let you know in advance, if your key features do not look like this, they do not, for example, the vertex is not a point, or your y-intercept is not 0 comma some value, it's going to get marked down. If your axis of symmetry is not x equals something, it's gonna get marked down. Your first step in doing this should be identify A, H, and K. Again, this is based off the original equation, the general equation of a transformation. If you didn't write it down, if you forgot it, it's at the front of the board on a poster. A is 2, because A is whatever is in here. 2. H is the value that's here, but it must switch signs. Therefore, H is -6. And then your K value is here. It's whatever sign is there, so -2. If my vertex is at HK, that means it's at H, comma, K. That's my vertex. That is the main thing that you need for your sketch, because then you're going to go to your coordinate plane and you're going to ask yourself, where's my vertex? This quadrant, this quadrant, this quadrant, or this quadrant? -6, -2, -6, -2 is somewhere over here. Because it's a sketch, it does not have to be perfect. We will go back and label things once we figure out exactly where they are, but a sketch does not have to be perfect or precise. We will deal with precision later on in the semester. Next, you have to ask yourself, what type of function is it? What's the parent function? In this case, the parent function is x squared. We can see that because there's a 2 here. There's an exponent. Then we have to ask ourselves, is there a reflection? No. What does a equal 2 mean? It means it's going to be a little more narrower than usual. There's your sketch. Eventually, it is going to hit the y-axis. I probably didn't draw it to scale, but I still need to go back and solve for the y-intercept, which I will do at the end. Max or min? You have to ask, is this a low point or a high point? I see that the graph reaches a low point and then bounces back, therefore it's a min. And if my min is at y equals k, that means my min is at y equals -2. My axis of symmetry is somewhere here. That somewhere is at x equals h. That means x equals -6. Domain and range. Every quadratic has the same domain. It never stops going left, and it never stops going right. On an infinity, you're never going to put brackets. It's always, always, always parentheses. Range, how low did it go? We already said it's a min at y equals -2. So we know our range goes as low as -2, and it never, ever, ever, ever stops going up. Therefore, infinity. To solve for the y-intercept, x is 0 at your y-intercept. It is always 0, because it is when it crosses this line, the y-axis. At the y-axis, x is always 0. Therefore, what you do, you take your original equation, 2 times x plus 6 squared minus 2. You plug in 0 for x, and you solve. So f of 0 equals 2 times 0 plus 6 squared minus 2. This becomes parenthesis first, therefore 6 squared minus 2. Next you do exponents, so 2 times 36, because 6 squared is 36. I'm going to subtract 2. Next I do 36 times 2, which is 72 minus 2. And I'm get the final value of 70. Therefore, my y-intercept is at 0, comma 70. So we do number 3. Number 4. We're going to sketch and find the key features of the equation. What you should notice is this is a circle. I know it's a circle because I have x blah 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 squared plus y blah 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 squared equals some value. The general equation of a circle was x minus h squared plus y minus k squared equals radius squared. So I have to find what h is, what k is, and what r is. In a circle, they both switch signs. So h switches signs from what you see. Therefore, h is 5, k, -3. Now the trick was that in our equation, we see a 49. That is radius squared. 49 is not the radius, 49 is the radius squared. That means we need the square root of 49 to know what the radius is. In this case, it's 7. The center is at hk, so my center is at 5, -3. My radius already found, it's 7. Now, you have to go sketch your circle, which is at 5, -3. That's my center. And to find what the actual circle looks like, from your center, go up 7, right 7, left 7, down 7. My scale is awful, so I'm going to just make a circle, and now it's going to look like a football. That's my fault because I was lazy, didn't put my dashes. But if you put your dashes, you'll see that it's perfect. I'm going to give you the dashes on the test, so don't even worry about that. Next, the domain. On a circle, you're always going to have brackets for the domain and the range. Here, if you want to see how far left you do 5, because that's my x value. I'm going to subtract 7, because that's my radius. So 5 minus 7 is a -2. On this side, you do 5 plus 7. That's 12. If you want to find how low and how high you went, you do -3 minus 7, just -10. -3 plus 7, which is 4. So my domain goes from -2 to 12. My range goes from -10 to 4. Remember, it's always low number to high number. Always. Whether it's a domain or range. Low to high, low to high, low to high. Number 5 looks weird. It says, given the parent function is x to the power of 500. Guess what? It just behaves the same way. It's still the same thing. What you have to do is translate. It wants us to write an equation that describes a horizontal translation left. That means h is -3. A vertical stretch by 4. That means a is 4. And a vertical translation down 6. That means k is -6. I'm going to just plug it in to my general equation, which again is x minus h plus k. In this case, there's going to be a 500 here. But it's the exact same thing. That means f of x equals a is 4, x minus a negative is plus 3 to the power of 500 minus 6. Voila. 6, the hard part is you have to read it. It says Tom Brady threw a football to Randy Moss that Randy Moss caught 50 feet away. So that means Tom Brady's here. Randy Moss is here. He throws a football that he catches a distance of 50 feet away. The football reached its vertex 30 feet away from Tom Brady at a height of 8 feet. That means somewhere on this path, it's 38. Because if this is how far, then the y is how high. Next it says Tom Brady then stood on a table that was 5 feet high. That means Tom went up 5 feet plus 5 feet. If it helps, draw your little table. Now Tom Brady's here. He should really be bigger than that, but sorry, I messed up. Tom Brady then stood on a table that was 5 feet high. How high does Randy Moss need to jump in order to catch the football at the same distance of 50 feet? We already established from our word problems. That means everything will go up by 5. If this went up 5 feet, that means the vertex goes up 5 feet, and Randy has to jump 5 feet. So that means Randy jumps 5 feet, and my vertex will go up 5 feet. So I'm going to be at 30, comma 13. And that's the end of the study guide.